हेलो। चार्ज लगा दूं यार। हो गया चालू। Hello and welcome to the Studify Plus. In the discussion of network analysis, we are in the discussion of two port networks. और टू पोर्ट नेटवर्क्स में हमने बात कर ली है किसके बारे में? हमने बात कर ली है y पैरामीटर के बारे में, हमने बात करी है z पैरामीटर के बारे में और इनके कुछ कनेक्शंस की हमने बात की थी. हाउ यू कैन कनेक्ट टू y पैरामीटर नेटवर्क्स, हाउ यू कनेक्ट टू पोर्ट यूजिंग z पैरामीटर. And we have seen the series and parallel connection of these two networks. Now let's go to the next part. We will introduce one more parameter, and that parameter is important for analysis of voltage controlled current source like our BJT and MOSFET. So next parameter we will talk about is H parameter model or hybrid parameter model. In hybrid parameter model we take one variable from input and another variable from output. So let's talk about H parameter model, and we are having the general discussion on H parameter model. This is not based on BJT or MOSFET. Specifically you can transform, means suppose I am saying some current is I1, because for my two port network current is I1, but the same current in the BJT will be IB, base current, if you are analyzing the common emitter transistor. For us the output current is I2, but when you are transforming that two port parameter into the BJT, for BJT that I2 current will be the IC, collector current. So we can transform that. So our next agenda is to talk about H parameter model, and we will see how H parameter model works. So let's talk about the next agenda. Next is H parameter model. Hybrid model, H parameter model. H parameter model is useful for analyzing the bipolar junction transistor. All kind of transistor you can analyze with the help of this mode, because this will gives you some significant parameters. Some parameters are known as input impedance, that will tell you how your amplifier will behave, means behavior of amplifier with respect to loading. Some parameter will gives you the output impedance. The output resistance will tell you how fast, means in case of capacitive coupling or for the case of maximum power transfer you can adjust the load. And the H parameter model will give you the information about the voltage gain, current gain. So this is very important to analyze all kinds of transistor. So useful for BJT or MOSFET, in which case for in small signal. Why I am calling a small signal? Because whenever you want to analyze your transistor with respect to for amplification purpose, that in that case this is very important model to analyze the BJT. the dependent source model. So this parameter is known as H parameter. We will define H parameter for our two-port network. So for two-port network, for a two-port network, what we can say? We can say that we have our standard procedure to define the two-port parameter. So first I am taking this. This is our two-port network. And we are trying to define the two-port network with the help of what? With the help of H parameter model. One, 2, 3 and 4. What we are having here, as usual, we will define out of this 4 variable, 2 variables are independent variable and 2 variables are dependent variable. This is V2 and I2, 2 voltage and current at output port, and here we are having V1 and this is I1. For this two-port network, I will define which model? H parameter model. And what it says that V1 I2 as a function of H11, H12, H21, and this value is H22 times of I1 and V2. So I can say in this case which one is dependent variable. So in all previous cases we have taken input port as a dependent variable or output port as a, or you can say voltage as a dependent variable or current as a dependent variable. But here we are having what is dependent variable and what is independent variable. So you can say I1 current at input port and V2 are independent variable. While V1 and I2 are dependent variable. So if you want to analyze a two-port network, with the help of H parameter, then what you have to do? You have to make I1 equal to 0. You have to make I1 equal to 0 means you have to replace your input port by open circuit and then you have to apply the output port by short circuit. This is the idea. So to analyze, we have to replace what two steps we have to follow. Step number 1, make I1 equal to 0, or you can say you are replacing your input by open circuit. And what is step number 2? Step number 2 is what? V1 I2, so I1 V2, this form. So you can say step number 2 is making V2 equal to 0, and V2 equal to 0 means output port is equivalent to short circuit. These two steps we have to perform to calculate all the H parameters. And if you want to analyze the H parameter for the BJT, you can say what is value of V2? for common emitter transistor, you can say that you will learn in your analog circuit course. What is V2? V2 is VCE. What is I2? I2 is IC. What is I1? I1 is IB. And what is V1? V1 is base voltage. So you can arrange this for bipolar junction transistor also. Input current, input voltage and output voltage, and all this for a small signal. You don't need a model to analyze the transistor at BJT at DC. We need to analyze the BJT with AC signals, with small signals. Correct? Let's go to the next part. What next part says? Next part says that V1 is equivalent to, let's write this in equation format. So V1 is equivalent to, what is V1? V1 is H11 multiplied by I1, H12 is multiplied by V2. So you can say V1 is H11 I1 plus H12 V2. And what is V2? You can say I2 is equivalent to H21 I1 plus H22 V2. This is our equation number 1, and the second is equation number 2. So we can calculate two parameters. We can calculate two parameters by replacing input as open circuit, or you can say by making I1 equal to 0. So if I make I1 equal to 0, if let's say I1 is equivalent to 0. I1 equal to 0 means input port is open circuited. Input port is open circuited means we can calculate the V1 divided by V2 ratio. If I1 equal to 0, this is V1 divided by V2 by making I1 equal to 0, and this parameter is known as H12. This parameter is known as H12. In case of amplification, this parameter will be less than 1. In case of common emitter transistor, this parameter is what? A negative parameter. But yes, it is defined only for the linear networks. For non-linear network, it will not work. H12. Now let's calculate the other parameter. Next, by making I1 equal to 0, one more thing you can calculate. By making I1 equal to 0, one more parameter you can calculate, and that parameter is what? Ratio of I2 divided by V2. This all parameters you will get in the data sheet of the transistor. So this is I2 divided by V2, and I2 divided by V2, this is what? By making I1 equal to 0, this parameter is known as H22. This parameter is known as what? H22 parameter, or you can say this is conductance parameter or admittance parameter. What is the V1? In this is the hybrid parameter, and all the units are different. When you talk about V1 by V2, this you can say volt by volt, unitless quantity. One of the parameter is having unit mho. If you are having the unit ohms, so all parameters in the H parameter model having different units. So this is V1 by V2, that represents attenuation factor for a linear amplification. This is 1 by H22. 1 by H22 represents the output impedance of that network, of that device for which you are analyzing the H parameter model. Next is what? Next you can obtain by making, next parameter you can have by making V2 equal to 0 by applying a short circuited output. So you can say Case 2, if you make V2 equal to 0. If you make V2 equal to 0, how much I can have? If you are making V2 equal to 0, I can have the ratio of V1 by I1. V1 divided by I1. We can call this parameter as short circuit input impedance. The ratio of input voltage and input current is known as input resistance. So you can call it short circuit input impedance or input resistance. You can say this value is, this parameter is H11, and you can call it short circuit input impedance. Fine. What is next parameter? So by making V2 equal to 0, one more parameter is I2 by I1, that is known as current gain. Usually you call it beta or alpha of a transistor. So alpha means for common base and beta means for common emitter. So you can say I2 by I1. I2 divided by I1 by making V2 equal to 0. This parameter is known as H21. So all this parameter provides the information about what? All this parameter provides the information about your 3-terminal transistors, BJT and MOSFETs. So you can say S21 define current gain of the transistor. Current gain. So these are 4 parameters, and these are 4 parameters we will talk about. Now it's a very interesting to transform, means analysis is same, we will solve question on that also, but let's talk about how these parameters are related to the Z parameters and Y parameters. So your first equation is what? First equation is this. From H parameter, V1 is equivalent to H11 I1 plus, here we are having H12 V2. Correct? And the second equation we are having is I2 is equivalent to H21 I1 plus H22 V2. These are the equation we are having from the Z parameter. Now we are having these are the equation we are having from the H parameter. This is which model? H parameter model. And here we are having which model? Here we are having one more model to analyze the 2-port network, that is Z parameter model. And what is Z parameter? Z parameter is V1 is equivalent to Z11 I1 plus Z12 I2, and V2 is equivalent to Z21 I1 plus Z22 I2. Correct? And here we can say you can transform this into each other. There is a relationship between, and relationship between both. You are having the relationship between Y parameter and H parameter. You can have the relationship between Y parameter and Z parameter and Y parameter. So this is which model? Z parameter. Now what we can observe here in Z parameter, what is Z parameter? V1 is represented as linear combination of I1 and I2, while V2 is also represented as linear combination of I1 and I2. V1 and V2 both are represented as a linear combination of I1 and I2. But when I look at the H parameter, if I rearrange the equation, I can say I can have this arrangement. Let's look at this. When I look at the V2, V2 can be represented as a linear combination of I2 and I1. So I can write what? I can write this. H22 into V2. H22 into V2 is this term. H22 into V2 is equivalent to minus H21 into I1 minus H21 into I1 plus I2. And when you find the value of V2, we can say the value of V2 is equivalent to minus H21 divided by H22 into I1 plus I2 divided by 1 divided by H22. Now here you can say, what is V2? V2 is now represented as a function of I1, I2. If V2 is represented as a function of I1 and I2, this is the same, means for a given network, or if we are defining the same network using this two parameter, then this two equation must be equal. If we are doing it for the same network, can I say this two equation must be same? And if this two equation must be same, you can compare the coefficient of I1. So V2 is what? Some constant times of I1 plus some constant times of I2. Here also V2 is what? Some constant times of I1 plus some constant times of I2. If this is so, can I say Z21 parameter is given by what? Z21 parameter is given by what? This. Here we are taking the coefficient of I1. Here also I am taking the coefficient of I1, and that parameter is what? Minus of H21 divided by H22. Correct? What is next? Next, we are having the coefficient of I2. What is the coefficient of I2? The coefficient of I2 is Z22, and here the coefficient of I2 is 1 by H22. So you can say Z22 is represented by 1 divided by H22. We are trying to establish a relationship between Z parameter and H parameter. Likewise, you can have the relationship between Y parameter and H parameter. Everything you can relate. So this is one of the two parameters are available. What is the problem with the second equation? Means when you look at the Z parameter, you can observe that V1 is also represented as the linear combination of I1 and I2, and here we are having I1 but we don't need I2. So let's modify this. Can I say our equation is, V1 is equivalent to H11 I1 plus H12 V2. But suppose I want to represent this in terms of Z parameter, then what is the problem? V2 is the problem. We don't need V2. We want, if you want to write the equivalent Z parameter for this in terms of H, then you should say V1 should be function of I1 and I2. But we don't need V2. So V2 is given here. We will write this V2. So can I say, instead of writing V1, we will write V2. And what is V2? V2 can be given by H11 I1 plus H12 H12, instead of V2 I will write V2, I will replace V2 by this minus H21 I1 plus I2 minus H21 I1 plus I2 divided by what? Divided by H22. So now you can say your whole V1 equation is now also function of V1, I1 and I2. So you can say V1 can be represented as H11. If I take I1 as a common, H11, and from here I can take minus H12 H21 divided by H22 times of I1. Correct? This is one of the equation. And what is second? Second is the function, the coefficient of I2 is what? H12 divided by H22 times of I2. Means this variable is multiplied here and divided by H22. Correct? Now you can compare by your standard equation. Whatever is the coefficient of I1 is known as Z11. When you look at this equation, whatever is the coefficient of I1 is known as Z11. So this factor is known as Z11 and this factor is known as Z12. So you can say Z11 is given by H11, H22 minus H12 and H21, and here it is divided by H22. Correct? And you can say here Z12 is defined by H12 divided by H22. So what is my two-port network? So two-port network, the Z parameter equivalent of this two-port network is given by this. If I write the H parameter, can I say H parameter is H11, H12, H21 and H22. When I write the determinant of H parameter, what will be the determinant of H parameter? When I find the determinant of this matrix, can I say the value of del is H11, H22 minus H21 into H12. Correct? This is the idea. Now can I say I can write this value Z11 is equivalent to del divided by H22. Correct? Then we will write Z12 parameter, it is H12. Always remember what is del. Del is determinants of this 2 by 2 matrix. So this is H12 divided by H22. What is Z21 parameter? Z21 parameter comes from here, minus H21 divided by H22, and this is 1 divided by H22. So H parameter can be converted into Z parameter if you rearrange the values in this form, and this value is equivalent to what? The equivalent Z parameter. This is equivalent to Z parameter. Z12, Z21 and Z22. Correct? Now we know the condition of reciprocal and symmetrical network. A network is said to be a now we can find the condition for symmetrical and reciprocal condition for H parameter also. When a network is said to be a symmetrical network, is said to be a symmetrical network if these values are same. If these values are same. if these values are same, then your network is said to be symmetrical network. So can I say the condition for symmetrical network condition for symmetrical network condition for symmetrical network. And what is the condition for symmetrical network? We know all the condition means for Z parameter that condition is equivalent to what? Z11 equal to Z22, or for Y network this is Y11 equal to Y22. But if we are talking about, but we know the Z equivalent of H parameter, so you can say this is Z11 and this is Z22. So you can say for H parameter, what I can say, for H parameter I can say this value del divided by determinant divided by H22, this value should be equivalent to what? This value should be equivalent to 1 divided by H22. This value is cancelled. If this value is cancelled, you can say determinant, if determinant is 1, you can say the H parameter model is symmetrical. And what is determinant equal to 1? This equal to 1 means this H11 H22 minus H12 H21, this product is equivalent to 1. If H parameter is satisfying this condition, then you can say this parameter is symmetrical in network. Let's go for the next. And what is next? Next we are having the condition for reciprocal H parameter, reciprocal network. Reciprocal network. The condition for reciprocal network. And what is reciprocal? A condition for reciprocal network is H12 equal to or Z12 equal to Z21. Means for Z parameter we are having the rule. If Z12 is equivalent to Z21, or you can say if Y12 is equivalent to Y21. This is the condition for reciprocity, reciprocal network in which for Y and Z. Now we are interested in the reciprocity condition for H parameter. Reciprocal two port using H parameter only if H parameter is given. So you can say in this case these two values must be equal. So you can say minus H21 divided by H22, this value should be equivalent to H12 divided by H22. When you look at this, this is 1 divided by this. When you go to the previous one, yes, 1 divided by H22. Okay, this two parameter must be same. So minus H21 divided by H22 and H12 divided by H22. So when you are having this relationship H12 equal to minus of H21, then you can say your network is a reciprocal network. So we can have all the condition of reciprocity and the condition of symmetrical network. Both you can obtain with the help of, and you can convert this you can convert this into y parameter also. What is the story of y parameter? Suppose you want to convert this into y parameter. So conversion of the y parameter is also a very simple task, because in y parameter we represents I1 as a function of V1 and V2 and I2 as a function of V1 and V2. From this theory you can write, means suppose I want to establish a relationship between this. Suppose we are interested in the relationship between y and h parameter. Suppose we want to establish a relationship between y and h parameter. So you can say, what is your h parameter? The h parameter is given by this. H parameter is given by this. V1 equal to H11 I1 plus H12 V2, while I2 is equivalent to H21 I1 plus H22 V2. This is our y parameter, and suppose we want to convert this parameter into, this is our h parameter. Suppose you want to convert this into y parameter. This is for this is our y parameter. Suppose we want to convert this into the which parameter? We want to convert into y parameter. Suppose we want to convert this into y parameter, and what I can say here, I can say the y parameter is I1 is equivalent to y11 V1 plus y12 V2, and you can say I2 is equivalent to y21 V1 plus y22 V2. This is which parameter? This is y parameter. So in y parameter you can say we are having I1 and I2. I1 and I2 both can be represented as a linear combination of V1 and V2. Here also a linear combination of V1, V2. So here also you can write one parameter direct. Suppose you want to convert this into y parameter. So what we want? Here we are having V1, I1 and V2. So we want to represent I1 as a linear combination of V1 and V2, that I can write. So when you go to the first equation, what this first equation says? First equation says that V1 is equivalent to H11 I1 plus H12, correct? We want to represent I1 as a combination of V1 and V2. So you can write here V1 minus H12 V2 divided by H11. This is I1, correct? Or we can separate it. 1 divided by H11 V1 minus H12 divided by H11 into V2 is equivalent to I1. And if this two equation represents the same two-port network, then this two equation must be same. Means what is the value of Y11? The value of Y11 is given by the value of Y11 is given by 1 divided by H11. And if you are interested in the value of Y12, Y12 is the coefficient of V2 and Y12 is given by minus of H12 divided by H11. These are two equations. So you can say you can transform it into Y parameter also. Then we will see how you can connect this Y parameters. Now what is next? Next, when you look at the another equation, here we are having I1, I2 and V2, but we want to represent I2 as a function of V1 and V2, but V2 is there but V1 is not there, so I1 is not there, so let's replace I1. So can I say the another formula is this? What is I1? The I1 value is V1 minus H12 into V2 divided by H11. Correct? And what is your second equation? So when you go to the second equation is I2 is equivalent to H21 into I1, but I1 is not needed because we want to represent, if you want to transform this into Y parameter, I have to write the I2 as a function of V1 and V2. So it is function of what? It is function of I1 and V2. So let's replace this. This is V1 minus H12 V2 divided by H11, and what is next? The next part of the equation is H22 into V2. H22 into V2. When I compare this, can I say what is the coefficient of V1? So coefficient I1, I2 can be written as V1 times of what? V1 times of this. H21 divided by H11 plus we are having V2 times of how much? V2 times of we are having H21 minus H12, H21 into H12 divided by H11. Correct? This whole value is negative, so let me write negative sign here, and with positive what we are having? At positive we are having H22. These are the coefficient of V2. And when you compare this from the standard equation, I can say this parameter represents Y21 and this parameter represents Y22. So you can convert this into any parameter, Y parameter, Z parameter, both are fine. You can convert it into any parameter. And if you will evaluate the condition, all the condition will be same. Means I can say, what I can say? I can say that what is Y11? So Y11 is given by 1 divided by H11. 1 divided by H11. What is next parameter? Next parameter we are having is Y12 minus H12 divided by H11. What is next parameter? The next parameter we are having is Y21. So Y21 is H21 divided by H11. And when you talk about this parameter, so again you can say this is H22 into H11, minus h12 and h21. This represents the determinant of h parameter. When you go to this represents determinant of this matrix. So you can say this value is what? This value is del divided by h11. And this is which representation? This representation is known as y11, y12, y21 and y22. These values are equal. And again, if you find the condition for reciprocity and again you find the condition for reciprocity and symmetrical network, you get the same condition, and you can perform opposite of that also. Suppose you want to represent h11 in the case of z parameter or y parameter, that is also possible. Correct? So don't try to remember it, just focus on the equation. Equation will give you the correct answer. Don't try to remember these things, not necessary. Fine. So this is a relationship between y parameter and h parameter. Now let's go to the next part, and next part is very important. How you can connect a two-port network, or which configuration will give you direct addition of h parameter. So can I say we are interested in the discussion about topology as we have discussed in y parameter and z parameter. If some two-port networks are connected in, parallel combination, you can add y parameters. If two-port networks are connected in the series combination, you can connect z parameter. Now, which topology will satisfy this? We want to, because what is the variable? Variable we are having is this: input voltage and output current. So at input we want to add voltage, and at output we want to add current. So whenever you want to add voltage, you have to have a series combination of two-port network, and whenever you want to add current, you have to have parallel combination of the network. So can I say the topology is known as series parallel connection, or you can say series shunt connection. So which topology can add h parameter? Series parallel connection. Connection of two-port networks. Series parallel connection of two-port networks can give you the additive effect. And let's see how we can have the additive effect. How we can have the additive effect? Let's see. So can I say here we are having, let me write it here. Here we are writing first h parameter model, here we are having second h parameter model. Correct? We are having two port networks, and let me define here two ports. This is two port networks. These are two port networks, correct? And I am calling this voltage, as V1 prime, and I am calling this current as I1 prime. And the first two-port parameter is known as H prime. What is H prime? H prime is given by this. When I say something as H prime, when we define something as H prime is defined by this. H prime is defined by this. H11 prime, H12 prime, H21 prime, H22 prime. And this times of correct for the first two-port parameter. We are talking about which part? This part. And here I am writing what? Here I am writing this part is V2 prime and the current which is going inside the two-port is I2 prime. Correct? This is your first two-port network and we want the additive effect of this two-port network. What is next? Next we are having this. Next we are having this. The second thing we are having is second two-port network, and this two-port network is having potential V1 double prime and current is I1 double prime. Correct? Here you can say we are having the potential V2 double prime and current we are having I2 double prime. And this I am defining, this is a H parameter of double prime network. And what is H parameter for this? The H parameter for double prime is given by H11 double prime, H12 double prime, H21 double prime, H22 double prime. Correct? These are two networks. These are two networks. Now how I can aid this network? So look at your topology. When you look at the topology, what you can say? You can say that in H parameter model, we are having this. First, if you want to add voltage, and second you want to add current. So when you can add the voltage, you can add the voltage when you are having series of something. So can I say I can have this, a series connection of this. How to have a series connection? It's a very simple. Just connect this by, this is external connection I am using here, white pen. And here I am saying that this is the series connection. What I can say? I can say that if this voltage is V1, if this voltage is V1, how you will define the V1? V1 can be defined by V1 V1 dash, V1 prime plus V1 double prime. Correct? And if you mention a current I here, I1 here, if current going into the network I1, so current coming out from the network is also I1 and current coming out from here is also I1. So this you can say that in this case I1 is equivalent to I1 prime is equivalent to I1 double prime. I1 double prime. All currents are equal because same current will enter here, same current will come out from here, same current will enter here, same current will come out from here. So you want to add the voltage at input end. So if you want to add the voltage at input end, this is the story. Suppose you want to add the voltage at output end. Suppose you want to add the voltage at output end, you have to have the parallel, you have to add the current at output end. So you can say suppose you want to add this. So how to connect it into the parallel? The parallel connection is the easy thing. This is the parallel connection. White. And this is the parallel connection. Correct? And here I can connect this. Here I can connect all this. Correct? And this is series and parallel connection of the two-port network. So here I can say this value is what this parallel connection means. This parallel connection means what? That if I take this voltage as output voltage, if I am mentioning this voltage is V2, and if this current is I2, by looking at the network I can say if my both the references are same, then I can say V2 is equivalent to V2 prime plus V2 double prime. Why I am saying so? I am saying this because the same voltage will appear here and the same voltage will appear here. And what is I2? So you can say I2 is summation of two currents, because when you apply the KCL at the top node, let's say this is a node and you are applying the KCL at node, so incoming current is what? I1, I2, and outgoing current is what? I2 dash and I2 double dash, or I2 prime and I2 double prime. So you can say this value is I2 prime plus I2 double prime. I2 prime plus I2 double prime. If this is so, I can write the individual H parameter matrix and then I can add it. So can I say, so which topology can add H parameter? Series parallel connection. So can I say the first equation will looks like this. V1 I2 for first I can write what? For first I can write V1 dash, V1 prime, I2 prime. Or let me write it in the next page. H parameter for first two-port network. For first two-port. The H parameter for the first two-port, and how it will looks like. So let's write the H parameter model. Can I say here we are having V1 prime I2 prime, this value is equivalent to what? This value is equivalent to H11 prime, H12 prime, H21 prime, H22 prime times of I1 prime and V2 prime. Correct? This is our first equation. What is second equation we are having? The second equation we are having is the two-port network for H parameter for second network. And what is second network? So you can say V1 double prime, I2 double prime is equivalent to H11 double prime, H12 double prime, H21 double prime, H22 double prime times of what? Times of we are having this I1 double prime and V2 double prime. Correct? We are having two equations. And whenever we add these two equations, we will add corresponding right hand side and left hand side. And when you look at this, can I say I1 prime, I1 double prime is equivalent to I1? When you look at this, I1 prime, I1 double prime is equivalent to I1. So I can, when I add this, these two numbers are same. V2 prime and V2 double prime. Let's look at this. V2 prime and V2 double prime are also same. If these two numbers are same, I can take this 2 cross 1 matrix, I can take common. And here, when I add this V1 prime plus V1 double prime, V1 prime plus V1 double prime represents V1. And I2 prime plus I2 double prime, I2 prime plus I2 double prime represents I2. So you can say our whole equation will be what? Our whole equation, when I add this value will be V1 prime plus V1 double prime. Then we are having I2 prime plus I2 double prime. Correct? And this value is equivalent to, as it is given in the equation, we are adding both sides. So as it is given in the equation, this you can add this value because I1 prime is equivalent to I1 double prime and V2 prime is equivalent to V2 double prime. If these numbers are same, you can add this directly. H11 prime, H11 double prime, H12 prime, H12 double prime, H21 prime, H21 double prime, H22 prime, H22 double prime. This much of what? This I1, I can write this as a I1 because I1 prime and I1 double prime is same as I1. So I can write, because we are trying to write the equivalent of this. So I can write this as a I1. I can write this as a I1. And here we can write V2 prime and V2 double prime are also same. If V2 prime and V2 double prime are also same, we can write this value as what? We can write V2 prime and V2 double prime is same, and this value is equivalent to V2. This is I2. So this is equivalent Z parameter. So you can say the equivalent Z parameter H equivalent is given by what? H equivalent is given by H11 prime, H11 double prime, H12 prime, H12 double prime. What else? H21 prime plus H21 double prime, H22 prime plus H22 double prime. So in this topology, you can add in this topology, you can add the H parameter model. You can add the H parameter model when you are having this type of connection. Correct? So this is our discussion on which parameter? H parameter model. This is our discussion on H parameter model. There is one more parameter which is known as G parameter, but not needed here. Means G parameter is what? The analysis will be same. Just replace instead of V1 write V2 and I1 is a function of opposite of that. So we are not going to discuss that. Not needed. But this is very important to understand that H parameter is useful for your both of the very important devices of analog circuits. One is BJT and another is MOSFET. Slightly variation can be there, but yes, exactly this is how you analyze your three terminal devices, which is BJT and MOSFET. Now let's try few problems on this H parameter model, and then we will go to the next parameter, which is ABCD parameter. Okay, these are PYQs. So let's take first PYQ. What they are asking? They are asking H21 parameter for this network. So we will not calculate the H21 parameter. We will calculate all the parameters for this circuit. How we can calculate all the parameters, H parameter for this circuit? So can I say H parameter is given by you can calculate it directly also, there is no problem, but I will use this. If you want to write Z parameter for this is very simple. V1, V2. If you want to write Z parameter you can try, because this is the star formation. What is the Z parameter? Z11 is equivalent to 2R, Z22 is equivalent to 2R, and this is resistive network. Resistive network is always symmetrical, so Z12 and Z21 is equivalent to R. But we want to write the H parameter, so I can say the H parameter is given by what? V1 is equivalent to H21 I1 plus V1 is equivalent to H11 I1 plus H12 V2, and I2 is equivalent to H21 I1 plus H22 V2. This is our H parameter. A basic KVL can address, with the help of basic KVL we can address this problem. What they are asking? They are asking the H21 parameter. So for H21 parameter we have to apply a short circuit at V2. So let's apply a short circuit at V2. We are replacing our V2 by short circuit. We are replacing our V2 by short circuit. So I am replacing it by what? I am replacing it by short circuit. We are replacing V2 by short circuit. So V2 is equivalent to 0. So we have replaced the V2 by short circuit. If V2 is replaced by short circuit, which relationship we want? We want the relationship between I2 and I1. The I2 by I1 is known as H parameter. Okay, let's see how we can write this relationship. If this value is 0 and if this value is I1, can I say this current is also? This current is I2. Correct? If this current is I2, what is potential drop here? The potential drop here is plus minus I2 into R. Yes or no? This is the potential drop. If this potential is 0, this potential will be what? Minus I2 into R. Now you can write. What is this current? This current is, I am taking this point as a reference point. And I am taking reference equal to 0. If reference equal to 0, higher potential is 0, lower potential is minus I2 into R. Can I say? Higher potential is 0, lower potential is minus I2 into R. 0 minus minus of this value divided by R, which is current going from upward direction. So this current is what? This current is I2. And now a simple KCL can give you answer. If I apply the KCL at this node, let me call this node as N. Let me call this node as N. If I call this node as N, then KCL at N how you define the KCL at node N? The incoming current, one current is I2, one more current is I2, and one more current is also incoming current. So let me write this current as I1. Sum of incoming current equal to 0. So you can say 2 times of I2 is equivalent to what? Minus of I1. I am interested in 2:1 ratio, I2 by I1 ratio. So I2 divided by I1 ratio is equivalent to what? Minus of 1 by 2, and this parameter is known as H21. Minus 1 by 2 is correct answer for this question. Minus 1 by 2 is correct answer. So this is very easy question. Means in exams they ask the individual parameter. They don't tell you to write the complete equation. Let's take few more problems on H parameter. This is on ABCD parameter. Okay, this is one of the question. In this question they are asking about, when you look at the question, this question is asking about two parameters, Z parameter and H parameter. So let's write how we can calculate both. A 2-port, this is common data question. So this is usually 4-mark question, and the same theory is applicable to both the question. The first question is what is Z parameter? Second question is what is H parameter? So a 2-port network shown in the figure, a 2-port network excited by the external DC source. This is one of the DC source. The voltage and currents measured at V1, V2 by voltmeter V1 and V2. Okay, V1 and V2 are the readings of the voltmeter. Always remember it needs correct DC values. Average values of a DC is DC, and A1 and A2 are assumed to be ideal and indicated under following conditions. Means two things are given. Whenever V1 and V2 are written, these are not voltage sources. This is the value of the voltmeter reading. Voltmeter is connected in this way, parallel, and in series what is connected? A1 and A2. So I think this parameter, this must be A1. So A1 and A2 is what? A1 and A2, the reading of 2 voltmeter, it is given. And they have performed some operation here and they have given the result. What they are saying? They are saying that if you make S1 equal to open, if you make S1 equal to open, can I say if I make switch S1 equal to open, what is meaning of switch S1 equal to open? Open switch means I1 equal to 0. Open switch means what? I1 equal to 0. And if I make switch S1 open, S2 close, S2 is close, then A1 is I1 equal to 0. It is given. Then V1 is given as 4.5, V2 is given as 1.5, and A2 is given as 1. So it is, he is saying that V1 is given as 4.5, V2 is given as 1.5, and only current we are having is what? I2, The reading of voltmeter A2 is what? I2 current, and that value is given as 1 ampere. Correct? So they are asking what? They are asking two port parameters. So we can calculate, if input port is open circuited, we can find the ratio of V2 divided by I2 by making I1 equal to 0. This ratio is known as Z22, and Z22 ratio is what? 1.5. Correct? What is second? Second is we can find the ratio of V1 divided by I2 by making I1 equal to 0. And what is this ratio? This ratio is Z12, and Z12 ratio is given by 1.5, 4.5. So if we are writing the Z parameter, we can say Z22 is 1.5. So 1.5 is here, 1.5 is here, 1.5 is here, 1.5 is here. So these two options are wrong. Okay. Among these two, Z12 is 4.5. Here Z12 is this, Z12 is 4.5. You can delete the option, but okay, some more readings are given. If S1 is closed and S2 is open, if I say if S1 is closed, this switch is closed means no current is 0 at input port. S2 is open. S2 is open means the output current is equivalent to 0. So what you are doing? You are taking this. I2 current is equivalent to 0. If you make I2 current equal to 0, S2 open, the current I1 is given as 4 ampere. What else is given? A V1 equal to 6 volt. V2 is also equivalent to 6 volt. This is given. And A2 equal to 0 ampere. So current I2 is 0. Of course, whenever we replace the circuit by open circuit, the current will be 0. If this is so, we can find two more parameters. What is the ratio of V1 divided by I1? The V1 divided by I1 ratio is 6 by 4. 6 by 4 is 1.5. And here V2 divided by I1, that ratio is also 4.5. So you can say this is Z11 and this ratio is Z21. So this is 1.5, 1.5. Z11 is 1.5 and Z21 is also 1. So option C is correct here. Option C is correct here. Now what they are asking for the H parameter also. So here we have to convert Z into H. And how we can do this? So 1.5, 1.5, 4.5, 1.5. So you can say V1, V2 is given as 1.5, 1.5, 4.5, 1.5, 1.5, and this is I1, I2. Correct? Now we are interested in H parameter. And what is H parameter? So suppose you want to what we want to do? We want to transform this into H parameter. What is the equation for H parameter? So you know that the equation for H parameter is V1 is equivalent to H11 I1 plus H12 V2. And what is value of I2? Value of I2 is H21 I1 plus H22 V2. Is it okay? Now, what we want to say? We want to say this. Let's look at our first equation. The first equation is V1 is equivalent to 1.5 I1 plus 4.5 I2. And what is V2? Okay, what is V2? V2 is 1.5 I1 plus 1.5 I2. From this equation, we want H parameter. So how we can write the H parameter? H parameter we can say V2 can be represented for the same network. V2 can be represented by I2 minus H21 I1 divided by H22. So you can say 1.5 is coefficient of what? 1.5 is coefficient of I2, and here coefficient of I2 is what? 1 divided by H22, while minus of H21 divided by H22 is coefficient of what? This is the coefficient of I1, and here the coefficient of I1 is what? 1.5. So you can say 1 divided by, so what is value of H22? H22 is 1 divided by 1.5. Let's look at this. 1 divided by 1.5 is 0.67. Yes. So one of the parameter we can have is 0.67. What is another parameter? You know that 1 by H22 is 1.5. So you can say H21 is equivalent to minus 1. Because 1 divided by H22 is 1.5. 1.5 is cancelled. H21 is equivalent to minus 1. So let's look at this. H21 is minus 1. Only this can gives you. H21 is equivalent to minus 1. And one more parameter you can match. The value of H22 is 0.67, and here you can say H22 is 0.67. You can match remaining option also, because this set is not available anywhere in the all 4 options. Or you can go for remaining, means in second equation you can replace it. So this is the idea for calculating H parameter from the Z parameter, and this is one previous year question. Okay, this is for ABCD network. Okay, let's calculate one more thing. What they are interested in. Okay, so one question from book and another question from, these are 2 last questions from the H parameter model. And what these questions are asking? These questions are asking that we are having the hybrid, calculate the hybrid parameter. So as we know that V1, to calculate the hybrid parameter, V1, I2, these are dependent variables. This value is equivalent to H11, H12, H21, H22 times of I1 V2. So which relationship we want? If I make I1 equal to 0 in this equation, what are 2 equations we are having? V1 is given by H11 I1 plus H12 V2, and I2 is given by H21 I1 plus H22 V2. What first step I am doing? I am just replacing the output by a short circuit. What is our first case? First case we are taking V2 equal to 0. Let's take V2 equal to 0. This is our first case, that I am taking V2 equal to 0. So if I am taking V2 equal to 0, let me draw the circuit, how circuit will looks like. If I take V2 equal to 0, the output port short circuited, then we are having 1, 2, 2. Or let me draw it here. this value is 1, 1, 2, this value is 2, this value is 2, and then we are having 4 I1 dependent source is there. What else we are having? 1 ohm resistance is there. So let me write this as a 1 ohm resistance. And what they are saying, what we are taking, we are replacing our V2 terminal by short circuited. So this is V2 terminal is replaced by short circuited, and from here you are having current I2. And I am taking it is given that this value is V1 and this value is I1. Correct? By making V2 equal to 0, what we need to calculate? The relationship between V1, I1 and relationship between I2 and I1. Let's get by making V2 equal to 0. Let's say V1, I1 ratio. Okay. Fine. Can I say this current is I1 and this value is 0? If this value is 0, what is potential at this point? Let's calculate by this. You can say if this value is I2, what is potential drop here? I2. If this is 0, what is potential drop here? The potential drop of this point is represented by minus of I2. Correct? This current is I2, this current is 4I1. This potential drop is what? This potential is, this current is I2 plus 4I1. I2 plus 4I1. If this is I2 plus 4I1, I can say this potential drop is 2 times of I2 plus 4I1. Or let me write it more clear. This is current always enters from the positive polarity, so you can write this value is 2 times of I2 plus 4I1. Yes or no? I2 current is coming from here, 4I1 is coming from here, addition will go into this. And what is potential drop of this point? Let me call this point as Vx. What is value of Vx? So you can say the value of Vx is given by minus I2, the potential of this point, minus this value, minus of 2 times of I2 plus 4I1. So you can say the value of Vx is minus of 3I2 minus of 8I1. Correct? Now everything is available in form of I1 and I2. You can apply the equation to get the answer. So what will be the answer? The answer will be this. If I apply the KCL here, what is incoming current? The incoming current is I1. What is one more incoming current? So what is our idea? Idea is KCL at Vx. We are applying KCL at which node? We are applying KCL at this node, Vx node. So what is incoming current? Incoming current is I1. So I am writing I1. What is one more incoming current? One more incoming current to the node is I2 plus 4I1. Correct? Why we are writing everything in form of current? Because we want the ratio of I1 and I2. Because I1 and I2 ratio will give you S21. And what else we want interested in? This current is taken, this current is taken. What is current in this branch? The current in this branch is given by 3I2, because I am taking this current as a negative. So this voltage will be what? 3I2 plus 8I1 divided by 2. And sum of all this current equal to 0. means Vx is a negative number. If it is this negative number, this is 0, negative number, that value is positive, divided by 2 is the current. So I don't think any confusion is here. 3I2 plus 8I1 divided by how much? 2. Sum of this value is equivalent to 0. Now you are having direct relationship between I1 and I2. How I can write it? I can write like this. I1, if I take common, this value is 1. This is taken. This value is 4. The second point is taken. This value is also 4. Third point is also taken. And what is I2? I2 is equivalent to minus of I2. This value is what? 1, and this value is 3 by 2. So 8 plus 1, 9. Can I say 9I1 is equivalent to 3 plus 2, 5. Minus of 5 divided by 2, minus of 5 divided by 2, I2. Correct? And now we are having one of the parameter. What is one of the parameter? One of the parameter is what? I2 by I1 ratio, H21. And what is value of H21? The value of H21 is given by value of H21 is given by I2 by I1. And what is I2 by I1? You can say the I2 by I1 is 18 by minus 5. So 5 3s are, answer is minus of 3.6. Correct? This is one of the answer. Now what is second answer? Second answer, we can apply the KVL. What KVL we can apply? We can apply KVL in this loop to get another answer. What is value of V1? So you can say the value of V1 is given by KVL at input. If I apply the KVL at input, can I say V1 is equivalent to I1 into 1. V1 is equivalent to I1 into 1, this potential into this potential, Vx plus Vx. And we know the value of Vx. So V1 is equivalent to I1 times of Vx. What is the value of Vx? The value of Vx is given by this, minus 3I2 minus 8I1. Minus 3I2 minus 8I1. Or you can say V1 is equivalent to minus 7I1 and minus 3I2. But we know the relationship between I1 and I2. For the same parameter, the relationship between I1 and I2 is given. And what is that relationship? That relationship is this. I2 equal to minus of 18 by 5 I1. So let me replace this. I2 equal to, so you can say V1 equal to minus of 7 I1 minus 3 times of how much? Minus 18 by 5. Now you can say the V1 by I1 ratio is equivalent to what? Minus 7 plus 18 into 3, 54 by 5. And this value is given by (54/5) minus 7, 3.8. So this value is what? 3.8. This is the first parameter. Which parameter? H11 and H21 we have calculated. What next thing we have to do? The next thing we have to do is to perform I2 equal to 0. If you want to make I2 equal to 0, even we can use the simple approach. Because one dependent source is I1, you can make I1 equal to 0, I2 equal to 0, you can calculate Z parameter and then you can transform into H parameter. But we want to do it directly. So if I am making I2 equal to 0, what can happen to the network? Let's take the next case. Okay. V2 equal to 0. Now you have to make I1 equal to 0. Fine. This is independent variable, so you have to make I1 equal to 0. So if you make I1 equal to 0, you can find the voltage gain. So let's make I1 equal to 0 also. If you replace I1 equal to 0, how your network will looks like? The network will look like this. This is one network, 1 ohm. This is also 2 ohm. This is also 2 ohm. Now 4I1 is 0. Why 4I1 is 0? Because I1, we are taking I1 equal to 0, so 4I1 is also equivalent to 0, and 4I1 is a current dependent current source. So if current source is 0, we will replace it by open circuit. So 2 and 1 will appear in series. So can I say this resistance will be what? This resistance will be 3 ohm. Correct? What else is given? This value is given as V2. This value is given as V2. This value is given as I2. And what else? V2, I2. I1 is, I am taking as 0 because this is our condition, and this value is known as V1. A very simple network. Just look at the condition what we want from this network. If I am making I1 equal to 0, first I need the ratio of V1 and V2. Another I need the ratio of V2 and I2. So let's get this. Can I say if I am making I1 equal to 0, there will be no potential drop across this point. The potential drop across this point will be 0. And we are taking this point as our reference point. We are taking this point as our reference point. So if this is V1 and there is no potential drop, so V1 voltage will appear here. And can I say this is I2 and this is also I2. What current you can expect here? I2. So what is potential drop? 2I2. The potential drop is what? Here potential drop is 2I2. So if one relation I can write V1 is equivalent to 2I2. Correct? Now, what we can say, if I apply KVL here, what is KVL? V2 is equivalent to, what is current here? What is potential drop here? Potential drop here is 3I2. So, V2 is equivalent to 3I2 plus 2I2. We want S22 parameter. What is S22 parameter? S22 parameter is I2 by V2 ratio. So you can say the I2 by V2 ratio is one by 5. What one more parameter we need for this? One more parameter we need for this by making I1 equal to V2 equal to 0 is by making I1 equal to 0. I am taking I1 equal to 0. So V1, V2. We want relationship between V1 and V2. Can we have the relationship between V1 and V2? Yes. V2 is equivalent to 5I2. Correct? So V2 divided by V1 ratio, V1 divided by V2 ratio is needed. V1 divided by V2 ratio, V1 is 2I2 and V2 is 5I2. That ratio is what? 2 by 5. The analysis is same. If you are comfortable in the KVL and KCL problems, there is no problem in analyzing this type of networks. It is very simple to analyze this kind of network. You can directly solve using H parameter model. Let's take one more case. So here, what are the H parameter? We have all H parameters. V1 by V2 ratio is what? V1 by V2 ratio is H12. So this parameter is H12 parameter. Now let's go to the next thing. What is next thing? Next thing is this. This is one previous year question and they are asking the H parameter model. They are asking what? They are asking the H parameter model for this set network. E1 and E2. E1 and E2 are given these two voltages. I1 and I2 are current at input terminal and output terminal. For this, calculate H21 parameter. What they are saying? They are saying that calculate H21 parameter. And they have given the definition of H parameter also. So can I say H21, we are interested in this parameter. So we only need to write the second equation. So can I say I2 is given by H21 I1 plus H22 E2. Here you know that E1, E2 and I1 means the potential at output and I1 are two independent sources. So can I say if I am interested in H21, I have to make E2 equal to 0. The moment I make E2 equal to 0, this will be 0 volt. Then I am interested only in the relationship between I1 and I2. Okay, let's see how we can have this. If this is 0, we can solve this network very easily. If this value is E2 equal to 0, E2 equal to 0 means the output potential is equivalent to 0, and they are asking they are asking about something else. They are not asking about H21, they are asking about H12. So can I say for H12 I have to write the first equation. So can I say E1 is equivalent to H11 I1 plus H12 E2. So suppose I want to calculate the H12. For calculating H12, I have to make I1 equal to 0. Let's make I1 equal to 0. And by making I1 equal to 0, I have to calculate the relationship between E1 and E2. So if I make I1 equal to 0, this potential is 0. If this potential is 0, can I say the potential drop across this component is also equivalent to 0. So this value is what? E1. Correct? If this value is E1, what is current here? The current here is, I am taking this point as my reference and I am selecting the value of reference equal to 0 volt. So if this is E1, this is 0, what is potential, what is current here? This current is E1 divided by 2. If this current is E1 divided by 2, the current is not coming from here, this current is E1 divided by 2. Can I say this current is also what? This current is also E1 divided by 2, because you have to satisfy the KCL. So no current is going and coming from this branch. So if this is E1 divided by 2, the same current will come from here. And what is this? This potential drop will be E1 divided by 2 into E1. So this is E1. If this is E1 and again you are going negative to positive, so this voltage is what? 2E1. Correct? If this is 2E1, what is current going in this branch? The current going in this branch is E1 by 2. If this current is E1 by 2, E1 by 2 is going in this branch, E1 by 2 going in this branch, what is current coming from here? E1 current is coming from here. So you can say this potential drop is what? 2E1. So what they are saying, if this potential is 2E1 and when you go from negative to positive, you will gain the potential. So this potential is what? 4E2. 4E1. 4E1 and E2 are the potential of the same point. 4E1 and E2 are the potential of the same point. Then we can say 4E1 is equivalent to E2. And if we are interested in which parameter, if we are interested in E1 by E2 ratio, so you can say the E1 divided by E2 ratio is nothing but by making what equal to 0? By making I1 equal to 0, this value is known as H12, and H12 equal to what? E1 by E2 is 1 by 4. 1 by 4 is what? 0.25. This is correct answer. So I hope H parameter is clear. This is useful for analyzing. Okay, this is what? Okay, this is based on ABCD parameter. We'll talk about that also. Okay, one more question they have asked. This is again a previous year question, and let's talk about this question also. What this question is saying. What this question is saying, let's analyze. They are saying that calculate this value H11, and they have defined H11. H11 is the ratio of V1 by I1 by making V2 equal to 0. So let's calculate this. Let's make V2 equal to 0. So I am making this part, I am replacing this part by short circuit. If you replace this part by short circuit, you can say this represents V2 equal to 0. This represents what? This represents V2 equal to 0. Now we want H1, we want which ratio? We want the ratio of H11, V1 and I1. Okay. Let's apply a KCL here. If I say this current is I1, what is potential drop here? I1 into 1 is I1. So what is potential of this point? V1 minus I1. Now if we know the potential of this point, let's say this point is Vx. So how we are defining the potential? We are defining potential like this. If this applied potential is V1, there is a potential drop of I1. So V1 minus I1 is the potential of the Vx node. Let's apply one KCL at Vx node. If you apply the KCL at Vx node, what is incoming current? Incoming current is I1. So let's write this current as I1. What is outgoing current? Outgoing current, the current across resistance is always given by potential difference divided by resistance. So we are having potential difference V1 minus I1. If we are taking this potential V reference equal to 0. So V1 minus I1 divided by 1 is the current which is going away from the node. And what is one more current? V1 minus I1 minus 0 divided by 1. This is the current which is also going away from the node. And one more current which is going away from the node is 2I1. So how many currents are there? You can say the 1, 2, 3 and 4. We have wrote all the current 1, 2, 3, 4. 3 currents are going away from the node. This is going away from the node. This is going away from the node. This is going away from the node. Only one current is incoming current. So can I say I1 is equivalent to V1, this is cancel. So is equivalent to 2V1. And they are interested in the ratio of V1 divided by I1. So V1 divided by I1 is equivalent to what? 1 by 2. So we can easily analyze, we can easily calculate if you are comfortably in Kirchhoff's voltage law and Kirchhoff's current law. This is the only thing required to analyze the H parameter model. What we will do in our next class, in our next class, in last class, we will talk about the ABCD parameter, one more parameter T parameter to analyze the two-port network. I hope you have understood this.